Okay, this is going to be an example of doing a test about a mean from 9.3. It's the same example I did in the previous video, except this one I'm going to do the actual calculations on the calculator. So for a more detailed video of this exact same problem, check out the other video. It's just called 9.3 extra example. And this one again I just added using the calculator. So the situation was a classic rock radio station claims to play an average of 50 minutes of music. Basically, you think that they are overestimating. You think they play less than that. So you want to test their claim. You go ahead and get a sample of 12 different hours during the week and record the number of minutes of music per hour. So here's your 12 values, and we want to test the claim about the mean being 50, or the alternative will be that it's less than 50. Okay, so what we would do, write our statements. Okay, so this will be done. Actually, before that, we do have to check the conditions. Okay, and we did this on the previous video, so I almost forgot. Make sure you check that it's normal. We didn't know anything about the population being normal, or the sample size was not greater than 30, so we do have to plot the sample data and check. And so when you plot the sample data, you're going to get a normal probability plot. So check the other video. We did that in a little more detail. Um, it was given that the sample was random, and then the independence, the capital N, the population size is greater than or equal to 10 times our sample size. So that was hours in a week, and we used 12, so there's more than 10 times that in a given week. Okay, so now we're ready to write the statements. Okay, again, we always are going to assume for the null hypothesis, HO, is that the mean equals some number. In this case, 50 is kind of that number. The alternative, the thing that we believe it's actually less than 50, H sub A. And then, of course, over here, we will define our parameter so your reader knows what you are testing. Okay, so when we did this by hand, we kind of put all the data into a list and got these from the one variable stats on the calculator. Okay, and then we went ahead and set up our picture. Okay, now the good news is the calculator can do this thing for you. It can actually draw the curve and show you what the p-value is and show you what the test statistic is. Okay, but just a real quick recap what we did. We assumed that the mean is really 50, like the alternative, or I'm sorry, like the null hypothesis said. We draw our curve based on that. Doing this by hand, you have to go ahead and find the test statistic manually, which is like finding a z-score, okay, which is this formula here, value minus mean, okay, and you can see the work done over here. And that is necessary to enter in as the upper bound for your TCDF. That would be the t-value of your actual sample. Okay, so the calculator can do this step for you. So what I'm going to do is pull up the calculator, and we're going to go into stat, over to tests, and I mean there's a whole bunch of tests, and these are really easy to mix up because they all look the same. Um, we're not doing anything with two samples yet. That's coming later. We're not dealing with proportions. Okay, so options 5 and 6, they're one proportion tests, are not going to be happening. And then the intervals below, z-interval and stuff, that's confidence intervals. So this one it's a t-test. Okay, we're using t instead of z because we did not know sigma. Right, we just knew the standard deviation of our sample. So we have to use a t-test. Okay, now there's two ways to do this. Okay, you either have the data, looking at the first line here, input data. Do you actually have a list of data? Okay, in this problem we did. Okay, so these numbers in here are from a different problem. So let's go and highlight data. Okay, my data, I already went in and entered it into list 1. So this was the data from list 1. We're doing this manually. I had this in here and I did the one variable stats. You don't have to do that. You can just put the numbers in. Okay, so that's going to be the 12 values. I'll go back over to the t-test. Okay, now for this problem, the data is our input. Mu sub 0, that's like your null hypothesis. It's h sub 0. We claimed that the mean equaled 50. Okay, if you look back at HO, it was mu equals 50. Okay, the list for our data is in L1. Frequency, we're just going to leave as 1 because we just entered the values in. I don't want to count them more than once or anything like that. And now for mu, this is the alternative hypothesis. Is it not equal? Is it less than? Is it greater than? In our case, it was less than. Okay, so we claimed that the mean was less than mu 0, okay, which was 50 again here, so mu 0 is 50. Our alternative hypothesis was that mu is less than that. Okay, and then we'll go ahead now, and you can actually select either option, calculate or draw. Calculate will just kind of give you the p-value and give you the test statistic and whatnot. I kind of prefer draw because it's good to see a sketch of this thing anyways. And this draws it out for you. It's drawn. There's your t-curve. This is doing all the calculations. It's giving you, this was the test statistic that we got manually. You can verify in the other video. So that's basically saying that our sample um, our sample was about 2.5 standard deviations below the claimed mean. Okay, and then of course you get the p-value here. P-value is how likely or what is the probability of getting a sample like yours or more extreme or farther from the mean. That's why it's a tail area over here. So our p-value was 0.0131. Okay, so just over 1%. Okay, so what that makes me think of is that if the mean really is 50, like we claimed it was, the results that we got, okay, our sample mean, I don't remember what the exact value was, um, but there's only about a 1% chance of getting that far from the mean or farther. So depending on what sigma is in this problem, if sigma, for example, I'm sorry, not sigma, alpha, the significance level, they didn't give us one. If we assumed it's 0.05, okay, that's what we need to compare our p-value to. Okay, so our p-value is less than alpha. So in this case, if sigma, I keep saying sigma, if alpha was really 0.05, we would reject HO, and our conclusion would be, if we go back to the other example here, okay, and this is kind of how we did it manually, we're just going to assume that alpha is 0.05. Since our p-value was less than that, okay, our sample was really unlikely to happen, the probability is so small, we're going to reject HO. So there would be evidence that the mean really is less than 50. Okay, so again, for more detailed, go back to the other video, same problem. I just wanted to show you the calculator method there.